Hello everyone, welcome to MANTECH tutorials. My name is MJ Man and I'm going to be your instructor for today. So today's tutorial is going to be on the design implementation of a wide area network. So I'm going to show you guys how we can take 1, 2, 3, 4 local area networks or more and then use it to form a wide area network. Sounds interesting? Let's dive into it. Alright guys, welcome back. So I'm going to take us straight to my labs. Here I have Cisco Packet Tracer, which is the tool I'm using, powerful software Cisco right there. Okay, so I have 4 networks, 4 local area networks, 4 switches and 2 routers. Quickly, I'm going to go into cabling. I'm going to use a copper straight through since I'm connecting on similar device types. I'm going to connect my respective networks to their respective switches. Copper straight through. Okay, so when connecting on similar device types like a computer to a switch, a computer to a router to a switch, we use a copper straight through. If I'm connecting similar device type, I'm going to use a crossover cable. If I need to make a point-to-point connection, I'm going to use a serial cable. If I need to get into console, I'm going to use a console cable. Okay, so that's Ethernet 0. And then, okay. Next, I'm going to use the same copper straight through to connect my switches to the router. I have fast Ethernet 2.1, gigabit Ethernet 0.1. Next, I have fast Ethernet 0.3, gigabit Ethernet 0.0, fast Ethernet 2.1, gigabit Ethernet 0.1. Okay, now I have my local area network on the left hand side and my local area network on the right hand side. To make it a wide area network, I need to connect them end to end in such a way that all end hosts, end devices or computers on my on the network on my left hand side should be able to communicate with all computers or end hosts or devices or on the network that is in my right hand side. So what I'm going to do right now is look for a serial cable. I have a serial port here, serial 0/0/0, and then I connect it end to end. Alright, so that will do for cabling. Next thing I'm going to do is I'm going to go into each router and then configure things like my default gateway, IP addresses, subnet mask, and routing protocol. Okay, so first I go into router 1. I go into router 1, and if I could just exit. Okay, let me widen it up a bit so you can see clearly. Okay, so in order for me to make any changes, I need to get into config mode. But first, I need to go. Okay, enable privilege exec mode. I need to go into config mode. So I execute the command config terminal, short for configure terminal. Okay, so I'm in terminal. There are some basic housekeeping I need to do. Things like host name. Host name is my router's name, by the way. So I like to use MANTECH 1. If you notice, you see my prompt has changed from MANTECH 001 to MANTECH 1. Next, I'm going to configure no IP domain lookup. Next, I'm going to go into console to do further housekeeping. Line console I could type line console 0. So I'm going to do login synchronous, and then I'm going to do no exec timeout. Finally, I'm going to save my work and then exit out of console. Now, quickly, in order for me to make a change into a port or an interface, I need to go into the interface. Makes sense, right? If you need to make a change or if you need to walk inside of a room, then you have to get into the room. Okay, so quickly, let me view all interfaces, IP interfaces on my router. So I'm going to execute the command do show IP interface brief. Okay, so I have 3 gigabit internet, 2 serial internet, 1 VLAN. First, I'm going to go into gigabit ethernet 0/0. So I execute the command interface gigabit. If I could type ethernet 0/0. Okay, you can see my prompt has changed to config-if, which means I'm inside of the terminal. Take note of these markers. You can see gigabit ethernet 0/0 says protocol up. Gigabit ethernet 02 says administratively down. Same thing with serial. Same thing with the second serial interface. Okay, so quickly I'm going to assign IP address to my first interface. IP address. I'm going to use the 10 network, which is the class A IP address. So I say 10.10.10.10. So the first 3 octets, that's the 10.10.10, is the network portion, while the last 10 is the host portion of my network. So I'm using 10. With other computers on the network, maybe I'm going to use 1, 2, 3, 4, 5, 6, or any number, but I'm using 10 because when I go to configure the computers on that very network, I'm going to make sure on the portion that says default gateway, I'm going to supply this 10.10.10.10 as their default gateway. Their default gateway being their way out of the network. Makes sense, right? All right. So my subnet mask is going to be 255.0.0.0. And why is this so? Because this is a class A IP address. So I hit enter. I bring up the interface by saying no shut for no shutdown. Okay. So I save my work. Do right. All right. So next I'm going to go into the second interface, which is gigabit type gigabit ethernet 0/1. My prompt has changed again. Quickly I assign IP address type IP address. This time around I'm going to use a 192 network, which is a class C IP address, 192.168.8.10. Remember, 192.168.8 is the network portion of the computer, while the 10 is the host portion of the address. Okay, so my subnet mask is going to be 255.255.255.10. Sorry, .0. And why is that so? Because this is a class C IP address. So I hit enter. Next, I'm going to bring up the interface by executing no shut, which I said is short for no shutdown. So I quickly save my work. Do right. Okay, so next I'm going to go into my serial interface. So interface, if I type interface serial 0/0/0. Okay, so quickly I'm going to assign an IP, a class B IP addressing, and I'm going to use 172.0.0.1. 172.0.0.1. Subnet mask is going to be 255.255.0.0. And why is that so? Because it's a class B IP address. Okay, I get an error. Okay, so 172.20.20.1, 255.255.0.0. Okay, still getting an error. Oh, my bad. IP address 172.0.0.1, 255.255.0.0. Okay, so what else? I need to bring up the interface by doing or executing no short. Okay, I need to save my work. All right, so for now I am done with router 1. I've configured all 3 interfaces on router 1, so I'm going to go out of router 1, and then okay, you can see the serial interface here is still red. It's not connecting, it's not up yet. And why is that? Because in order for a serial interface to come up, both ends need to be configured first. So I'm going to go into router 2, and then I'm going to go into config. Okay, so quickly I'm going to bring it up. This is enable config terminal. So my basic housekeeping: host name this time is going to be MANTECH 2. Quickly, no IP domain lookup, line console 0, login synchronous, no exec, okay, no exec timeout. Perfect. And then I'm going to save my work, do right. Now I'm going to go out of console, and then first things first, let me go into my first gigabit interface. So interface gigabit Ethernet, if I can type 0/0, good IP address. Okay, so here I'm going to use a network in the class C range. Yep, I'm going to use an address in the class C range. Okay, and what would that be? I'm going to use the 200 network. 200.200.200.10. Yes, with 10 being the host portion of my network, which is also my default gateway. So I have a subnet mask of 255.255.255.0, and then I bring up the interface by executing no short. Okay, I save my work, do right. Quickly I go into this next interface 0 gigabits Ethernet. Let me expand this. Gigabit Ethernet 0/1 IP address one network. Okay, let me use a class B IP address in the 169 range. 169.20.10. Subnet mask being 255.255. Type 0.0. Enter. Bring up the interface and save my work. Right. Okay. So next I'm going to go into interface serial 0/0/0 IP address 172. If I could remember, 172.0.0.2. Alright. 0.0.2. Subnet mask is going to be 255.255.2.0.0. I'm going to bring up the interface by executing no short, and I'm going to save my work. Do right. Okay, so that concludes my router configuration for now. So I'm going to exit. Okay. All right. So, okay, you can see my serial interface is up. You can see the green blinking already. Okay, so next thing, I'm going to configure all computers on my network. I'm going to start with this guy here. I'm going to go into desktop. I'm going to go into IP config. So I'm going to be configuring my IP statically. I'm not going to use dynamic IP. So I used the 10 network here, 10.10.10.1. Okay, subnet mask. My default gateway is HOV.10, DNS server.10. Okay, so I'm going to leave my IP version 6 to DHCP for automatic negotiation. And I think I'm done with this. I go in here, desktop, IP config. Here I used the 192 network, which is 192.168.0, 192.168.8.1. Subnet mask is going to be .0. Okay, this is going. I'm going to leave it to JCP, and I'm done. Yeah. I think I just finished configuring this guy, right? Excuse me. 192. No. This is wrong. This is a compression for the 10 network. 10.10.10.2. 255.0.0.0. 10.10.10.10. 10.10.10.10. 2. Okay. This is static. Okay, so let me be sure. Okay, that 1, that's 2. So from here, I'm going to start the 192. 192.168.8.1. Control C, Control D, 0, Control C. Okay, so 192.168.8.1. The next one is going to be 8.2. So 8.2. Okay, I'm going to leave this to DHCP. Okay, so I'm done with this. Let me be sure. This is going to 0, 1. Okay, gigabit internet 0, 1. Alright, that's cool. Okay. So I come down here. Let me be sure of something. Where did this go? 0, 1. Alright. Okay. So this is going to be on the 200 network. If I remember correctly, 200.200.200.1. 200.200.1. Subnet mask. Default gateway 200.200.200.10. Control A, Control C, Control V. Okay. I'm going to leave this to DHCP. The next is going to be dot 2. Dot 2. Okay. I'm going to leave this to DHCP server. I'm done with this network. I come to this guy. I think this guy has the 169 network. Okay. This guy has 169 network. So I'm going to go into my IP config, and it's going to be 169.168.20.20.1. If I am correct. Control copy. Control V. Control V. Okay. 0, 5. Okay. This here is going to be dot 2. Dot 2. Okay. 0, 0. Cool. So I'm done, but let me be sure of something. Config gigabit ethernet 0, 1. Okay, cool duplex. It's on 20.20.10. Right, excellent. Okay, so one last thing before I test my network. I need to configure a routing protocol on each router. That means I need to tell the router, or I need to populate the route information table with the default gateway of all interfaces attached to that router. Okay, so quickly, I'm going to go into router 1. Let me expand it a little bit so you can see. Okay, so I have, let me see, and exit. Right. Okay, so enable config terminal. Now, in order for us to configure a routing protocol, you have to go into the You have to go, you have to get inside the router. Okay, so the command to execute there first is router RIP. RIP is the protocol. RIP is short for routing information protocol, route information protocol. Okay, so you see my prompt changed to config router. So in order for you to configure the router, you need to get into the router. So next, I'm going to add my routing protocol now. I'm going to add all the networks. So first, I'm going to say something like network. The first one I had is 10.10.10.10. Enter. Network 192.168.192.168.8.10. Next, and the last one is network network 172.0.0.1. 172.0.0.1. I think I'm correct. Alright. So I think that is all. I also need to save my work. Right. So I'm going to hit exit. Okay, so I get out of router 1. It's the last step. I'm going to expand what I have here and to exit. Okay, so quickly enable config terminal. Okay, so from terminal I execute router RIP to get into my router. Now I add, here I have the 200 network, 169 network, and then the 172 network also. So first things first, network 200.200.200.10 100.100.10 network 169.20.20.10 okay. Network 172.0.0.0.2. I'm sure. Okay, so I save my work, do right, and then I go out of it, exit. So I'm done with all configurations now. What remains is for me to test my network. Okay, so I'm going to ICMP. Let me see, where is my Docker here? Okay, so watch this space for communication status, whether it is successful or it has failed. So I'm going to ICMP. I'm going to create a PDU. I want to ping this network from PC1 to the last PC on this network here. Okay, you can see ICMP failed. Now, what was going to happen again? Successful. Okay, so the first one, what happened in the first one is when PC1 is trying to communicate to the last PC here, PC1, this last PC, let me call it PC8. PC8 is not available on PC1's network. So PC1 needs to send an ARP request on the network requesting for PC8's network. PC1 knows PC8's IP address, but it doesn't know PC8's MAC address, and all computers need other devices' MAC address in order for them to create a frame to be transported on the local data link. So PC1 sends a broadcast across the network asking, who is PC8? PC8 gets the broadcast and say, okay, I'm PC8. PC1 say, please PC8, I need to communicate to you. There's something I need to send to you. I need you to send me your physical address, which is the MAC address. PC8 says, okay, sending it now. That's the process of ARP, Address Resolution Protocol. Now, after address resolution protocol, that's the first stage. That is why it failed. So after the first stage, PC1 is aware that PC8 exists on a different network. Since we're in a wide area network, PC8 exists on a different network. Not just that, PC1 knows that PC8 exists on a different network, and it knows all the routes to get to PC8. So PC1 now creates use PC8's MAC address to create a frame and then send it over the network. That's why on the second ICMP, I got a successful ping. Okay, so let me go into PC2 here, and I'm going to use command prompt, and I'm going to try to ping PC7. PC7 is on the 169 network, so let's see. Ping. Let me expand this. We need to see the status here. Ping 169.20.20.1. Okay. All right. You can see that the same thing happened here. The first response I get is timeout. Why did I get a timeout? Of course, the address resolution process is ongoing. So PC2 sends an ARP request, a broadcast on the network. PC2 sends a broadcast to the address 255.255.255.255, which is the broadcast address of all computers, all devices on all network. Now, PC7 gets the broadcast and reply back to PC2 with its MAC address. So on the second ping, I get a reply, the third one and the fourth one. Now watch, if I repeat the process, I'm going to get my response in full. You can see reply 1 2 3 4, 32 byte, 32 byte, 32 byte. No failure, no request timeout, because now PC2 knows PC7's physical address and the route to get to PC2. I could also check my route to PC7 from PC2 using a utility called trace route, abbreviated as trace RT. So I say 169.20.20.1, right? Yes, .1. Okay, so this is my route. In order for me to get to PC7 from PC2, I have to go through 10.10.10.10, which is the default gateway of the first network. Makes sense, right? Now, the next interface, the serial interface on that router on network 1 is 172.0.0.2, and then the next router, which is the next network, that is where you get 169.20.20.1. That is, the interpretation of this is that PC7 exists on 169 network, which is on the second router or the second network in whole. Okay, so I'm going to get out of my ping utility or command line here, and I'm going to ICMP from PC6 to PC4. What am I going to get? If I could just expand this. Okay, I get a failed. If I try it again, you see that it is successful. I try it from here to here. I'm sure it is going to fail, of course. And then I try it again. I'm sure it is going to be successful. Okay, guys, so this is how we form, or this is how we build a wide area network. All right, thank you guys. Thank you so much for watching. See you in my next tutorial. Please subscribe to my channel, MANTECH Tutorials. Hit the like button, leave a comment, and don't forget to turn on notifications. Please stay safe until I come your way again next time. Peace out.